And like I said, very similar to yesterday. In fact, you're using the exact same formulas. Speaking of formulas, let's just pull that up one more time. So you should have that formula sheet very handy. We're going to quick do a overview again. You should already have this written down. But for those of you that don't, tell me on this formula sheet what P stands for. Perimeter of the base. Tell me what H stands for. The height of the figure. Okay, not the height of the base, right? The height of the whole figure, the distance between your bases. And then tell me what B stands for. The area of the base. Okay, so again, those are the ones you're going to be using today. We're working with these two formulas today. Don't use any of the rest of these yet. We're not doing those. You don't need them. Okay, so those two formulas again with this set of notes here. So first thing you need to know, we're going to be working with cylinders today. A cylinder is a solid, right? It's going to be filled in that has two congruent parallel bases, just like a prism, okay? But the bases now are what shape? Circles, okay? Which is where the pi comes in. So you have your bases that are circles. Your height will always be the distance between them. So notice the height on this one is the horizontal because your bases are on the left and the right, okay? And then it's the right cylinder versus the oblique cylinder. Remember, the oblique one is just kind of like we pushed it a little and it tilted. Okay, so take a look at this picture. When we find the surface area of a cylinder, we're saying the area of every surface of that cylinder. But if you think about a soup can or just any cylindrical object, if you were to cut on the edge of that cylinder and then open it up, okay, so think about the wrapper of a soup can. If you were to cut that wrapper off and open it up, what shape do you get? A rectangle, okay? So essentially what you're finding is a rectangle and two circles, okay? So that's what this picture is showing you. We're opening it up. That means this length of the rectangle is the circumference of the circle, okay? So if we treat that like the circumference of a circle, if we're finding lateral area, it's the perimeter of the base, okay? My base is a circle. What's the perimeter of a circle? Circumference, right? Perimeter of a circle is the circumference of a circle. And circumference is pi times diameter, or 2 pi r, okay? So if I'm doing perimeter of the base times the height of the figure, another way you can think about this, there's two ways really, is instead of making it P, I could call it pi times diameter, right? And then my H. So if you want to think of that formula for lateral area as pi dH, you're welcome to. I'm not going to make you memorize that because it's just another formula. I will give you pH. This is the formula you're going to get from me, okay? But if you want to think of it as pi dH, you totally can. Or maybe you like 2 pi r better. Then it would be 2 pi r times h. That's fine too, okay? Please don't try to memorize them both. It's unnecessary. This will always be given to you. So just keep that in mind. You'll always get that. The surface area formula is the same as well. Surface area equals the lateral area plus 2 times the area of the base. So that means if we want to think of every part of it in terms of pi, the lateral area, we can still say is pi dH, okay, that's this, plus 2. Now let's think about B in terms of our base. Our base is a circle. B stands for the area of the base. What is B in a cylinder? Pi r squared, okay? So you can think of this surface area formula as that. I'm going to give you that top one every time. I'm not going to give it to you with pi in it. You're going to have to turn it into the pi information. So if you really want, you could memorize a new formula for those, but it's a whole lot of letters and a whole lot of room for oopsies. to just memorize a formula like that. I would just take your time and plug in what you know these equal in terms of pi, okay? And we're literally just going to do 2 problems like this, and then I'll give you some time to try it so that you can figure out what works for you, okay? So example 1 here, it says the radius of a cylinder is 4 and the height is 6. Find the surface area in terms of pi. So your answers are going to have pi in them, right? In terms of pi means leave the pi. If I were you, I would draw a picture. You don't have to. Some of you probably don't need to, but I think a picture is helpful, so I'm going to draw a picture. It says the radius is 4, so this number here would be 4, and then the height is 6. Okay, so essentially you're looking at a cylinder that looks like this. Now we're just going to baby step through it, okay? First thing we're talking about is what is the lateral area of that cylinder? What is the formula for lateral area? You'll have it in front of you, pH. Okay, so let's figure out what is P and what is H. What is P in this setup? It's the circumference of the circle, which would be what? Which is what? 8 pi. Pi times the diameter, right? Right now your radius is 4, so your diameter is twice that, so 8, right? So your perimeter is pi times diameter, or 8 pi. What's H right now? 6. Okay, so if I'm doing perimeter times height, I'm doing 8 pi times 6. What is that? 48 pi. So your lateral area is 48 pi square inches, okay? Notice we didn't plug the pi in. We multiplied the numbers times pi, right? 8 times 6 is 48. Then attach your pi square inches. Okay, so that's your lateral area. Feels very similar to yesterday, right? We just threw some pi in with it. Wouldn't it be nice if that had landed on pi day? So close. So the surface area is LA plus 2B, same formula as yesterday anyway. What is LA right now?
48 pi.
48 pi plus 2 times B, okay? And we got to figure out what is B. So in this figure, what's B?
Pi times 4 squared.
Pi times 4 squared. Pi times the radius squared, okay? So pi r squared, or 16 pi, is our B. Well, in the formula, B goes here, so we're going to drop in 16 pi. Silly question, but how do you simplify that? Right, we need to multiply 2 times 16, so we have a 48 pi plus a 32 pi, and now you can simplify that to what? 80 pi. Add those 48 and 32 to 80, attach your pi, and then it is square inches. Okay, so your lateral area is 48 pi square inches. Your surface area is 80 pi square inches. Just so you know, on quizzes and tests, the question will look like this. Eventually, I'll teach you volume for this stuff. So on like problem number 1, it'll say LA equals blank, SA equals blank, V equals blank. So you're just going to be solving for each of those pieces. So make sure you're showing the steps to figure out your lateral area. I know it's not your final answer on the book questions, but you do need it. So make sure you're showing that with it. Okay, why don't you, actually let's set it up together. I'm going to draw the picture with you, and then I'm going to have you try it on your own. And I'll just come around and then we'll do it together. So it says a soup can is 4.5 inches high with a diameter of 3. Okay, it's 4.5 inches high now read the question. How much paper is needed to make a label that will cover the sides with no overlap? What are you finding?
Surface area of just the bottom part,
And
not
like,
the.
away because the bases are gone.
There's no paper on the top and bottom of a soup can, right? It's just wrapping around. So you're finding lateral area right now, okay? So do that. Set this up, see if you can solve for the lateral area for me, and then we'll talk it through. Okay, so if we're looking for lateral area equals P times H, then what is P? 3 pi, right? Pi times the diameter. They gave it to you as a diameter, so don't double it, right? It's already a diameter. So it's 3 times pi for P. What's H? 4.5. Okay. Now here's the deal. Normally on a problem that's a word problem like this where it's an actual soup can, what do we usually do? Plug it in, right? We don't leave it in terms of pi because it's a weird thing to say. I need X pi square inches or inches of paper. So on this one, you could just plug it in, but I'm going to show you in terms of pi first. So if we left it in terms of pi, you would go 3 times 4.5. So it would be 13.5 pi square inches. Okay. If we rounded it,
For the homework, could we just leave it in pi, or would you rather just plug it in?
it depends on the question. If it's a real world problem like this, plug it in. If it's just here's a figure, it'll say leave it in terms of pi typically. On the test, I'll tell you what I want. Yeah, but most of the time, you'll leave it in terms of pi. So if you plugged this in, this would be 42.4 square inches. Okay, now that's the end of the problem. You're done. But let's just pretend that we also were going to find surface area because I want you to try one more surface area. So surface area is the lateral area plus 2 times b. Okay, so I'm going to leave this in terms of pi. I'm going to put 13.5 pi right here plus 2. How do you find b right now? Area of a circle. So pi r squared, and r is what? 1.5. If your diameter is 3, then your radius is 1.5. So pi times 1.5 squared. 1.5 squared is 2.25 times pi. Okay. So this is 13.5 pi plus 4.5 pi. So when we simplify that, you get a surface area of 18 pi square inches. Okay, so if it's in terms of pi, that's what you would do. If it's rounded, then you just plug the pi in. But a lot of the time, it's in terms of pi. Any questions on that? That's what you're doing today. So it should feel really familiar, right? pH and LA plus 2b, but just don't forget pi. And then here's the other thing, guys. Don't start putting pi into every problem. When does pi show up? Only if there's circles. So if there's a prism, don't plug pi in. Okay, that's also really tempting because people are so used to working with pi after today that they're like, oh, I'm just going to put pi in everything. Don't do it. It's not there.